Oh, hey guys. Hey. I'm Vadym. I came here to talk to you about some gas laws. Yeah. So, here we go. One of the most amazing things about gases is that despite wide differences in chemical properties, all the gases more or less obey the gas law. The gas laws deal with how gases behave with respect to pressure, volume, temperature, and amount. One important person is Robert Boyle. He was born in 1627 and he died in 1691. But you know something? I think my friend Addison knows more about him than me.
Robert Boyle made the law, Boyle's Law, or the pressure volume law, that states that the volume of a given amount of gas held at constant temperature varies inversely with the applied pressure when the temperature and mass are constant. Another way of describing it is saying that their products are constant. When pressure goes up, volume goes down. When the volume goes up, pressure goes down. From the equation above, this can be derived. P1V1 equals P2V2 equals P3V3, etc. This equation states that the product of initial volume and pressure is equal to the product of the volume and pressure after a change in one of them under constant temperature. For example, if the initial volume was 500 milliliters at a pressure of 760 torr, when the volume is compressed to 450 milliliters, what is the pressure? Plug in the values P1 equals P2V2. We challenge you to do that at home. You know, there's another scientist here, Jax Charles, but I think Vadym knows more about him than I do.
Hey again. Jax Charles, very interesting person. He was born in 1746, he died in 1823. What he did actually was, he invented a law. This law states that the volume of a given amount of gas held at a constant pressure is directly proportional to the Kelvin temperature. You know, another good guy, Gay-Lussac. And Joseph Gay-Lussac, good guy, very smart, yeah. He was born in 1778, died in 1850. Addison knows about more than him.
Joseph Gay-Lussac made Gay-Lussac's law, the pressure temperature law. Gay-Lussac's law, the pressure temperature law. This law states that the pressure of a given amount of gas held at a constant volume is directly proportional to the Kelvin temperature. That law was made by Joseph Gay-Lussac himself. As pressure goes up, temperature also goes up, and vice versa. Also, the same as before, initial and final volumes and temperatures under constant pressure can be calculated. Now we have Amadeo Avogadro. He was born in 1776 and died in 1856. Vadym's an expert.
So, Avogadro. Avogadro gives the relationship between volume and amount when the pressure, temperature are held constant. Remember, amount is measured in moles. Also, since volume is one of the variables, that means that a container holding the gas is flexible in some way and can expand or contract. If the amount of gas in the container is increased, the volume increases. If the amount of gas in the container decreases, the volume decreases. For example, if the amount of gas in this trash can decreases, then the volume decreases. It's exactly like he said. It's honestly the truth. He spoke the truth. Just like another good guy, John Dalton. Addison knows more about him.
John Dalton invented Dalton's law of partial pressures that states that the total pressure of a mixture of non-reacting gases is the sum of their individual partial pressures. The pressure in a flask containing a mixture of 1 mole of 1.20 mole O2 and 1.80 mole N2 will be the same as the flask holding 1 mole of O2. Partial pressures are useful when gases are collected by bubbling through water. Displacement. The gas collected is saturated in water vapor, which contributes to the total number of moles of the gas in the container. An example would be a sample of H2 was prepared in the laboratory by the reaction MgS plus 2Hc Aquarius to MgCl2 Aquarius
another one
plus H2G. 456 milliliters of gas was collected at 22 degrees Celsius. The total pressure in the flask was 742 torr. How many moles of H2 were collected? The vapor pressure of H2 at 22 degrees Celsius is 19.8 torr. We have another scientist here. He did it with non-ideal gases. His name is Jonas Walls. He was born in 1837 to 1923, and I think Vadym would be very interested to read.
Good guy. Don't have enough time to tell you about him today, but come back next week and I got you. See you later.